Friday transportation seminar of the winter quarter. So the students are probably happy that this another quarter down and finals week coming up next week. So today we're very pleased to have Kristie Gladhill to talk about her master's thesis that she just recently completed on safety, exploring traffic safety in urban form. So we do broadcast these live over the web. You've heard this many times before. So if you ask a question, you need to use the microphone, or I'll come around and give you the portable microphone so you can get your question in. So with that, I'm going to turn it over to Kristie.
Thank you very much. Sorry, getting used to this. First of all, I'd like to acknowledge Chris Monseer, my advisor in my graduate program, and also my master's team members, Dr. Kelly Clifton and Dr. Jim Strathman. Also fellow students Nikki Wheeler, who helped me get going with ArcGIS, and Nathan McNeil, who generously shared some business data that I used, and the Portland State University ITS lab for the opportunity to work there and learn so many things during my program. An overview today, I'm going to go through an introduction, data, descriptive and quantitative analysis, the model building description and results, and go through conclusions and recommendations. Now, streets have many users and many functions. We have safety as a primary concern, though, because transportation is the main function of streets. Safety and design and layout of streets goes back as far as Roman times. Design has very long-term effects because once the infrastructure is in place, it's very unlikely to be replaced, or if it were replaced, it would be rather costly. Starting in the mid-1800s, city designers such as Olmsted started assuming that grid was less safe than layouts that had less through streets. And that became a component that was even codified into the design and layout of streets. So they assumed it was safer, but let's look at some of the studies that have been done. In 1957, Marx looked at traffic crashes in the LA County area. He was only looking at right-angle crashes. He found that most crashes were at intersections. He found more crashes at four-legged intersections than at three-legged intersections, and that limited access areas had less crashes than grid layout. But there were some problems with this study. He did not adjust for traffic volume being different in different areas. He also did not include crashes on major bordering streets. In 2006, Kim and Brunner on Oahu did a crash study for the entire island, so it was not only urban areas, but also agricultural and military areas. They overlaid a uniform grid cell over the entire island and pointed out that even though there are major factors with human factors and vehicle factors in crashes, it's also good to understand what's happening with land use and other factors. So they included some land use, employment, and economic activity. They also assigned all of their crashes to the nearest intersection in their study. In 2009, Dumbow and Ray published a study where they looked at loops and lollipops versus grid. Their data were from San Antonio, Texas. Now, they used census tracts for their spatial unit, and those tend to have roadways on the periphery of each of the spatial zones. So there becomes the question of what do you do with crashes that are on the periphery? They felt that crashes on the peripheral roadways should be included in either zone that they were associated with, so they essentially double-counted crashes. They found that limited throughway areas push the traffic problem onto adjacent arterials rather than having a lower overall crash rate. They also felt they were providing one of the first empirical studies looking at this question of whether it's really safer to have a loops and lollipops layout than a grid design. In 2009, also Riffett and Tay had data from Calgary, Alberta. They had more than just loops and lollipops versus grid. They set a scale of 4 different types of layout, ranging from grid through warped parallel and something called mixed that was not completely loops and lollipops, but kind of the catch-all if it wasn't one of the other 3. And they decided to deal with the crashes on the periphery by excluding them. They found that limited through designs were safer. Well, this led to me looking at wanting to do an empirical study for data in Portland. I wanted to look at the relationship between traffic safety and urban form, but I wanted to be able to include all crashes equally and not have this philosophical issue when I'm starting a technical problem of should I or shouldn't I include the peripheral crashes and how do I count them appropriately. So I decided to use the idea of Kim and Levine and have a uniform spatial grid that I overlaid over the city of Portland. There were 1,284 grid cells. They're about 1/10 of a square mile each. It's about 1670 feet on a side. And then I took all of my other data and aggregated it into these grid cells. So if I had point data, such as crashes, I could determine which grid cell they fell into. If I had line data, such as streets, I could determine which grid cell they were in, and I could aggregate things such as the total street length within that grid cell. And if I had data from polygon shapes, such as data by TAS, so I had population data by census tracts or whatever, I reapportioned that polygon data into the polygon of my uniform spatial grid. So looking at the data of interest, there were, of course, crash data. The city of Portland has geocoded their crash data since about 1998, so those were available. I decided to use data from 2005 through 2007 because it's good to have a span of years to get more data, but you don't want to have such a long span that there's likely to have been more possibility of infrastructure change in that time, and that was the most recent available at the time I started the study. Within that crash data, there were about 60% were PDO, or property damage only, so no injury. There were only 0.4% fatalities. As you look at the spatial design of where the crashes fell, they certainly were concentrated in the central business district. You can also pick out some of your favorite major arterials. You can see Southeast 82nd Street very clearly. You can see other arterials such as Powell, probably Interstate going up. We also decided to exclude freeway crashes from this study because it was felt that that was a different type of structure than what we were looking at, trying to understand more urban form and neighborhood streets. So these are non-freeway crashes, even though you can still make out I overlaid the freeway, but you can still make out where the freeways are because getting on and off the freeway, there tend to be a lot of intersections and a lot of crashes. Looking at the crash data and a histogram of the types, there were over 29,000 crashes in those 1,284 grid cells. 315 of the cells had 0. And just kind of zooming in on that one area so you can see more, we had a lot of cells that had very few crashes, but there was a fair distribution of crashes at different levels. I'm sorry. Okay, so we also will see some different spatial patterns. I'm just going to jump ahead here. We looked at vehicle crashes already. Now we've got pedestrian crashes. There were over 500 pedestrian crashes. Notice that 99% of those were injury crashes, and 5.8 of those were fatal, so more than 10 times the fatality rate if a crash involves a pedestrian than vehicle-only crashes. And again, you can still kind of make out major roadways and arterials with the pedestrian crashes. Again, very heavily concentrated in the central business district. Bicycle crashes, there were also more than 500 bicycle crashes in the study. 95% of those involved injury, and 1.5% of those were fatal. Outside of the central business district, they tended to be a little bit more dispersed. And I should mention that Oregon is a self-reporting state, so we only have crash data if a crash is reported. So if there's less than $1,500 of damage to a vehicle or neither vehicle is towed, there doesn't have to be a crash report. So we do tend to probably have underreporting on the property damage only crashes. The primary crash types that we had, we broke it out by that, and you can see that the four at the bottom that were the heaviest ones, I wanted to do a diagram to help remember what type of crash that really is. So in an angle crash, you have a car crossing on a cross street in front of another one. That's the type of crash that Marx was studying in LA County, so it's not surprising he saw more of those at four-legged intersections because you have so many more conflict points there. Stopped crashes and straight are fairly the same thing. These were cars going the same direction and one overtakes the one in front of it, either a car that's already stopped or one that's still in motion. And the fourth most common one was cars that are going in opposite directions, but one is turning across the path of the other. So I know this gets a little small, but we have a big screen in here, right? Looking at the different spatial patterns you see when you break the crashes down by these four major crash types. The angle crashes were the highest and still look a lot like the overall vehicle crash spatial pattern. The stopped vehicle and the straight, over on the right, are very much a similar type of crash, and we see fairly similar distributions. The turning crashes have a little bit different pattern. So different distributions for different types of crashes. Also looking at the crashes by severity. Again, the vehicle crashes, you saw that bigger before, but wanted to include it so you could contrast it to the property damage only. Well, that was 60% of the crashes. So not surprisingly, we see a similar spatial pattern. With the fatal and injury crashes, so that's all types of injury, there's injury level A, which is a possible injury. Injury level A is incapacitating. Injury level B is non-incapacitating, and injury level C is a possible injury. So there's quite a contrast in those levels of injury. But fatal and all injury are shown here. And then I looked at just fatal, which fortunately are fairly low. We only had one cell that even had 2 fatalities out where 205 is leaving the city limits. And it turned out to be too small a data set to do modeling on. So I combined the fatal with the injury level A, which is the incapacitating injury. And you see a little bit more of some patterns emerging of where there may be problem areas for those types of crashes here in Portland. So going on into urban form data, I'll be looking at exposure, connectivity, demographic, origins and destinations, and transit accessibility. On the urban form, I used vehicle miles traveled. I got some data from Metro, from their transportation model that was based on the volumes on different links, and then multiplied that by the length of the links to calculate a vehicle miles traveled. And you can very strongly see where the major arterials are in the Portland area. I also got V over C data from Metro's transportation model and used that to get an average for the grid cell. So looking at V over C values, volume to capacity, if you're at 1, you are completely at capacity, which is usually not going to work very well. But you can see we have heavier concentrations of V over C. Interestingly, not downtown in the central business district so much as in some particular areas in the region. The average free speed, it was also based on posted speed in the Metro transportation model. And you can see that we tend to have lower speed limits until we get more out to the peripheral areas or on some of the major arterials in Portland. For connectivity, I was looking at the same scale that Riffett and Tay had used. So I went through all 1,284 grid cells and assigned whether I thought it was loops and lollipops, mixed, warped parallel, or grid layout. And there were some, you can see the yellow were the ones that I really couldn't determine, generally because there were too few streets in them. So that dropped my total cells for analysis down below 800. But there's also a parameter of what % of intersections in an area are 4-legged intersections. And it was thought this might be a parameter that would be a good surrogate for this street layout. So I also calculated that and looked at that. And there are some strong similarities in the kind of spatial pattern you see between these 2 different variables. Demographic data, we got population data, again from Metro, from their ARLIS data set that's here at PSU. And you can see that we have the most concentrated population to the west of downtown, and then a very heavy high concentration on the east side of Portland. I also had data on housing units, which housing and dwelling units very much match the same as the population data distribution. Origins and destinations, well, where are people going to be coming from and where are they going to go? Well, there's going to be employment, right? Where do we have jobs? The central business district, again, has the heaviest concentration of employment. Where are there businesses? And these are the data that I got from a place online called Reference USA with Nathan McNeil's help. He'd already geocoded most of this. We see a lot of businesses in the central business district, but it's very interesting to see how they're dispersed throughout the city limits. We have them in quite a few locations. And then transit accessibility, I saved that because when you have now seen the population and the businesses and employment layout, you can see that our transit system is pretty well laid out for where people want and need to go. We've got transit stops throughout the area, helping people get to those major locations. So the independent variables that I decided to go forward with for my analysis and study were vehicle miles traveled, volume to capacity ratio, average free speed, and number of schools. That's been included in studies in other papers, and schools can sometimes be an indication of exposure. You tend to have more pedestrians, particularly children, in those areas. Connectivity, looking at how many intersections are there in a grid cell, what % of them are four-legged intersections, how much total street length do you have, major arterial length, and block size. Portland tends to have a fairly small block size compared to a lot of other cities. That would mean there are more intersections likely, and shorter distance between traffic signals may be an issue. So that seemed like it would be an interesting parameter to include. Transit stops and transit ons and offs. This was from TriMet data that we have in the portal database from 2007. For demographics, I decided to only use population. And for origins and destinations, employment and businesses. I had a longer list of possible variables, but I ran some Pearson's correlation and saw a lot of cross-correlation. So some of these variables were standing in for themselves and others. I did the modeling in different groupings to do some comparison. I grouped it by modes. So as we already looked at the data, the vehicle, pedestrian, and bicycle modes. By crash type for the 4 major crash types: angle, stop, straight, and turn. And for severity, as I mentioned, fatalities alone were too few data to get a good model. So I combined fatal with injury level A, but I also looked at fatal with all injury levels, just injury, and just PDO. I did a negative binomial model. Crashes are essentially a failure model, which Poisson tends to model well, but if you have over-dispersion, which I did have in my data, the negative binomial tends to provide a better fit. So I did the model building by adding one factor at a time using cumulative regression, a method described by Banfro and Hauer. And basically, as you add another factor, you look at whether the cumulative residual plot looks better. And how do you define better? Well, better, more centered around 0. The final cumulative is closer to 0. You've got tighter sigma limits. So I did my model building, lots of wonderful model goodness of fit numbers for those who are heavily into model numbers. But looking at the R-squared, sorry, I keep hitting that. For crash data, these are pretty good numbers, and particularly when you think about we had a lot more vehicle crashes. Getting an R-squared of 0.62 is pretty respectable. Obviously, in pedestrian and bikes, we had a lot less crashes, so it's not surprising we had a lower R-squared in some of these groupings. So the overall results of all these models, if you have a coefficient that's positive, that means that adding a higher value will mean you have more crashes. And I've color-coded them by significance levels. And looking at this across the board, the VMT, vehicle miles traveled, was significant in all of the model groupings. The other factor that was significant in all the model groupings is down at the bottom, businesses. Other than that, we see some differences emerging. The V over C ratio was significant in vehicle and pedestrian, but not in bike crashes, which is a little bit surprising because if you look right below that, average free speed was significant for bikes, whereas it wasn't for peds. Kind of wonder what's going on there, but one thought might be that bikes try to avoid areas that have high congestion, so they might avoid the high V over C areas, and they also might avoid high-speed streets. But since this study only included auto infrastructure rather than bike, we don't really have a way to separate that out. Also, looking at the V over C, it turned out to be more significant for the straight and stop crash types, considering that again, if this is perhaps an indicator of congestion, in congestion you have a lot more stopping and going, so a lot more opportunity for those types of crashes for a vehicle to not be paying attention and overtake the vehicle in front of them. Crash severity, the most severe crash severity of F&A did not show it as an issue, but it was significant for the other severity levels. Schools didn't really show up as significant, which is a little surprising. They were significant in the overall, but not with pedestrian, which is where you would expect to have more pedestrians around schools. Maybe it's a sign that people really obey school speed limits here in Portland, and therefore they slow down, which, you know, generally speed is a major factor in crashes, so slowing down would have a positive effect there. Transit stops were significant in many of the models. It's something you don't like to think about. The more transit stops we have, why would that contribute? It was a factor that correlated with some of the other things, such as where businesses were in that, but I had wanted to include it as a separate factor. Certainly saw it more with the crash types and severity it showed up, and in the overall vehicle. Transit on and offs were only significant in the pedestrian, which makes sense because immediately before you get on or after you get off of transit, everyone's a pedestrian, unless they're immediately hopping on their bike. Population was significant in most models, not for the bike model and not for the most severe crash type. So where people live isn't necessarily affecting the worst severity of crashes. Employment was only significant for the vehicle crashes, and that, oddly enough, was a negative coefficient, which would imply that as you lower employment, you get more crashes. Not sure, again, what's going on there, but one explanation might be if you think about the employment density was very much in the central business district, whereas the businesses, which were significant in everything, are dispersed throughout the area, but that has nothing about the size of the business. So if you have a large employer, they might actually have less driveways in and out. The employment, the businesses could actually be a sign of how many driveways we have, and that can also tend to affect crash rates. So, not sure. And in case you were wondering, the connectivity, it just didn't all fit on one slide. We would have never been able to see it all. And this was really kind of the heart of what I was looking for, is what happens? Is grid really less safe than loops and lollipops? And you can see that really, except in a few isolated cases, it was not significant. Now, since the Riffet and Tay scale was not a continuous variable, it was discrete in the models, it gets shown as the other types relative to it. So this is mixed street pattern relative to loops and lollipops, warped parallel relative to loops and lollipops, and grid relative to loops and lollipops. So warped parallel and grid were significant for bicycle, which seems to indicate that the more we get to there being a more grid-like structure, there may be more incidents of bike crashes. Angle and turn crashes turned up significant for all of these types compared to loops and lollipops. Kind of makes sense because as you get away from loops and lollipops, you have more opportunities for that type of crash to happen. The mixed street pattern, for some reason, was significant for the property damage only. Not sure I can say much there. Intersections and the total street length were also significant for bikes. So bicycle crashes tend to be more of an issue. As you get to more grid, you have more intersections in particular. There may be some cross-correlation of those factors. The 4% four-leg intersections was significant for the angle crashes. Again, makes perfect sense considering what type of crash that is. The major arterial length turned out to be significant for turning crashes, but block size was only significant for one of the severity levels. So I also looked at elasticity. So if you had a 1% increase in a particular factor, what would it have a comparable one? An elasticity of 1 would be 1% increase in the factor would be a 1% increase in the crash rate. So as you can see here with the elasticity for all the different factors for the vehicle crash model, the VMT had the strongest elasticity. So as vehicle miles traveled increase in the area, that will tend to drive an increase of crashes. Interestingly, average free speed has a negative elasticity, which seems to imply that if you go faster, you'll have less crashes. Doesn't make the most sense, but again, remember that those higher speeds in the Portland area tend to be on peripheral roadways. So it may be something to do with how we have the speeds distributed in the area. The pedestrian crash model, again, the VMT is the most significant. And we also see population being significant for the pedestrian elasticity. With the bicycle crash model, VMT, the average free speed way on the negative. As I said earlier, that might be if bicyclists are avoiding high-speed roadways, but I don't have a good explanation for that. Getting to where you have more intersections tends to make things also have a higher crash rate for bicycles. So now looking at elasticity instead of by model type, by factor. As you can see, the VMT had the strongest elasticity across all of the different groupings. V over C showed some. Average free speed had the surprising negative elasticity. Schools, almost no effect. The different street network factors relative to loops and lollipops, we see bike and angle and turn having a little bit more of an issue as you start getting to the grid. As you go down to the warp parallel, those are still significant, but as you get to the mixed, not so much. Bicycle has a strong elasticity to the intersections, and the non-freeway street length has some elasticity also for the bicycles, but not much for other factors, other model types. Transit stops, didn't see much there. Population, a little bit of elasticity. Employment, essentially no elasticity, but the businesses, some minor elasticity. So, in conclusion, the methodology I used of aggregating the crash data into a uniform grid has some advantages because it eliminates the need to exclude or double count periphery crashes. You can include all crashes with equal weight and do your study without having to worry about that issue. It also allows some visualization of the relative crash factors and the factor levels so that you can see how things are spatially laid out in your area. The percentage four-leg intersections correlated fairly well to the street network scale. I like the thought of that for further work because it's less subjective instead of me going through that and assigning it. Also, Rifat and Tay, I think, used all of their students in their classes so that they got more input, but I didn't have students in classes to put to work. It's also a continuous variable, so it works better in modeling. And since it's simpler to calculate than the time it takes to go through individual cells, you could do it in, you could extend the study, for example, to a larger area. Descriptive analysis showed that crashes tend to be concentrated downtown and along major corridors. We have much higher injury rates with pedestrian and bicycle crashes in Portland. And we do have issues with independent variables being correlated in this study. The negative binomial model results, we had significant factors across all models. Ones that were significant for many models were the VMT, the businesses, V over C, and population. The pedestrian and bicycle, we saw some differences in the significant factors, so some different concerns affecting those modes. And there was insight from looking at the groupings of models into issues specific for the different groups. Angle and turn crashes had more significant factors than many of the other crash types. The crash severity for similar factors was significant, except population was not significant for fatal and injury level A. And on the connectivity in particular, the percent four-leg intersections was not significant, which indicates that there seems to be no strong model. This model indicates no difference in safety between the loops and lollipops or the grid, contradictory to some of the other results that have been shown. The elasticity was highest for the vehicle miles traveled. Other factors had some elasticity that we saw. Some ideas for further work would be to apply the model to data predictions for the next few years and see how well it actually predicted the crashes that have happened since then. Being able to use something like the percent four-leg intersections rather than having to manually assign a street layout could allow you to do a study over a larger area. It'd be nice if there were more volume data. Always nice to have more data. Particularly something we felt was definitely a good indicator of congestion, because it seems like that's a factor that could be affecting things that we're only estimating at this point. It would be interesting if there could be data looking at bicycle and pedestrian connectivity, not just roadway, especially as Portland is embarking on their neighborhood greenways now as their more modern approach to bike boulevards, of specifically trying to get 80% of the population within a half mile of a bike facility and providing low volume neighborhood links for bikes that are parallel to a lot of the major auto arterials in the city. I did not consider spatial spatial correlation, so looking into that could be added. And some specific locations could be looked at in more detail to look at what could be done to mitigate crashes in that particular area. So the importance of this work, again, I feel is understanding the effect of the urban form on safety can help inform decisions that are made in planning and development and safety improvement plans for our area. The connectivity, it seems, does not have to be sacrificed at the expense of traffic safety. We can still have a safe roadway for vehicles, pedestrians, and bicycles, and a safe street layout that serves so many different modes. I love getting these pictures here on campus. You get so many modes in one shot. It's wonderful fun. And I also like this photo of the cycle track here on Broadway on the campus. Sometimes you can make those infrastructure changes a lot less expensively than we might think. This was mostly paint and some signage, but they were able to give the bikes a separation from the auto traffic. I know there's studies still underway to look at how much this seems to have improved the safety or not, but interesting to see how we can try different things and see what we can do to improve safety in our area. Are there any questions? Nick. He's behind you.
Thanks, Kristie. I thought your maps were brilliant. I really liked the grid layout and the way you were able to visualize all the different data that way. It was just fabulous.
Thank you.
You said that it looked like the street grid, the classic street grid, was indicated with higher levels of bicyclist
Right.
accidents. And I wondered whether you normalized that in any way by the relative different usage levels of bicycling. Because I think in Portland, the classic street grid neighborhoods tend to be where there's more cycling going on as opposed to other kinds of other parts of
I did not have any bicycle volume data to work with for that. So, yeah, that is a weakness of the study. Yes?
Did you deal with the peak hours at all?
Actually, the VMT data were from volumes during the peak afternoon to peak hour data. So it was essentially based on afternoon peak.
One more question. You said that you excluded the freeways. Did you exclude approaches to freeways as well?
Any ramps were excluded, but of course you've still got the intersections leading to them. And actually, one thing Dr. Strathman recommended might be interesting in a further study would be a factor for whether a roadway is adjacent to a freeway and see if that seems to be a significant factor. Kristie.
Kristie, that was a great presentation. Thank you for sharing that with us. So I was curious, if, as we all leave here, and if, I'm assuming a lot of us are transportation professionals or interested in this. So I have like a two-part question then. The first would be, so taking what you modeled here, what could we take from this so that, as we're thinking about the design and aesthetics of our urban forms, like what are the major things that we should be taking away from this as we apply it on the ground? And then I guess a step further would then be, what are the limits to whatever impact we feel like we could have? So if we were to design, keeping in mind these, four-legged intersections and that kind of stuff, like in the name of safety, but what are the limits to how far that can go, if you had any thoughts about that?
I think some of the things you could take away for design are, it seems like the layout in terms of grid versus loops and lollipops is not significant for the safety. So you wouldn't have to worry about that. You could continue with, if you want to have good connectivity, which can have a lot of other things that are benefits that we like to have. We're also very much trying, I think, in Portland and other cities, trying to have very vibrant streets where we have a lot of modes. So we have people walk, we have pedestrians, we have bikes, we have transit, we have so many things going on. And some of those showed up as significant factors here. So keeping in mind that, where we decide to let businesses develop might be a higher risk area. So recognizing that and thinking about, well, what can be done to mitigate it? Portland's doing so much with what they're doing with their facilities for bikes and pedestrians, even having the curb bulb outs. Retaining the on-street parking has been shown in some studies to continue to keep the crash rates lower, because doing things, kind of in the complete streets idea that help drivers to naturally keep their speed down tends to help make it safer for all users. I just heard Mark Lear on Tuesday talking at the WTS luncheon about the neighborhood greenways, and they're really looking at what they can do to make it safer for all modes. I mean, they were even talking about skateboards, which I'll admit aren't one of my favorites to see on streets, but they had pictures of people walking in the street, pushing the stroller, joggers, and the bicyclists. So in making it safer for bikes, they're really looking at making it safer for a lot of modes. They're, as he said, turning the stop signs so that the bikeways will tend to be through without the bikes having to stop, except at major crossings. They're doing some very creative designs where the bikes are crossing. So I think thinking about those extra steps that could go into, if we're going to create a situation that's likely to have an increased crash rate, what can we do on the other side to mitigate it? And the limitations of that, hard to say. You know, Portland's definitely looking at that with the bikeways, and I think it'll be interesting to see that. Most cities are looking at decreased speed means decreased injury rate. One of the sessions I went to at TRB, they were definitely talking about that issue in New York City and Detroit and a couple other cities. They had some very graphic ad campaigns that they'd gone through where the one that got to me was a child's face, and one half was a skull and the other half was a face. And they had two different speeds. You know, this speed kills, this speed, they're likely to still be alive. So, was there another question back there?
You aggregated the crash data into the grid format, and you talked about some of the advantages. What are some of the limitations or disadvantages of that type of aggregation?
Well, deciding what grid size you use can affect how your data analysis is going to be. If you get to, as your grid gets smaller and smaller, you practically might as well not have one at all. And if it gets too large, you're aggregating things so broadly. If you're interested in looking for specific problem areas, it might not pinpoint them, but it sure can put you close in the neighborhood. So I think that it's, you know, got some good value there, certainly for looking at the regional area. I know I've seen at the Metro Regional Safety Committee, they've put together some different maps of how can we try to visualize spatially how we're seeing crashes in the area. And the major corridors that you can pick out in my Chloroplus are the ones that show up on their maps. So they definitely have gotten to that same point. But, you know, if this might prove to be a clearer visual tool for at least a first pass, it can be hard sometimes to decide how am I going to spatially represent the crash data in an area. Sometimes they do like larger dots for larger numbers of crashes, and then they all start overlapping each other. So this gives you the advantage of being able to not have the overlapping, even though you're only seeing it for a whole grid cell, so you're seeing the pixelation, but at least you can see an area without something overlapping nearby. Yes?
You have quite a few cells where there weren't any crashes at all. Do your grid cells include stuff like Forest Park that's within Portland city limits?
Originally they did the 1284, but two things caused me to drop cells out of the modeling. One thing was if I had if I had no V over C values, I felt that I couldn't include that in the model because it was probably that I didn't have data, not that it wasn't there. And then the other issue was when I went and tried to assign one of the 4 Riffet and Tay street layout designs. If I felt I could not assign one, that probably meant there were almost no streets. Like some of the cells you would literally have one street running through it, and it's like, I can't call that any kind of layout. There just aren't enough streets here. So areas like Forest Park got dropped out because they just didn't have enough streets. You can kind of pick out where the hills are. Yes, Taya?
I had a bit of a question about like the source of the crash data, because you said it was from the city of Portland, is that right? Or
yes.
Are they getting their crash data from police reports or from insurance claims?
It's from the ORTSTA database, which is an archive housed here at PSU. We have crash data going back to, what, 96?
Yeah, I mean, there's only one source of reported crash data in the state, and that's ODOT. So ODOT gives it to the city of Portland. ODOT maintains all of the reported crashes, so it's only reported crashes. It includes, Oregon is a self-reporting state, as Kristie mentioned, so the onus is on the citizen to report the crash, and it does include some police crash reports that get merged with the citizen crash reports. It doesn't include any insurance reports, so it's just...
So these are only things that people have chosen to report to ODOT?
Yeah,
Right.
you have a legal responsibility to report a crash. So when you're in a crash, you have to report it. If there's a police officer there on those crashes, they're going to file a report. DMV is going to get that report, and they're going to come after you to file the report. So, but about there's not that there's forget the number. It's 30 or 40% of the reports include police reports. The other half are just citizen-only reports.
Okay, yeah, the impression I had, at least in Portland, and some of the statistics looked a little bit shocking with the bike and ped crashes, that they were such high injury and fatality rates, that in an accident that involves an auto and a bicycle, if there's no property damage and no injury, I think it's the protocol of the Portland Police Department to not report that as a crash.
That is true.
Probably the case, yeah.
Yeah,
So I think there are a lot of crashes that are happening that just aren't getting reported because
Right.
nobody was injured.
So yes, I think the underreporting is probably much more of an issue with the bike crashes than with the overall vehicle crashes. Yes, that's probably certainly the case. Yeah.
But if you were interested in doing further research on the bicycle data, because I know that's something that people are really interested in, there might come a time where that that study needs to be done. We do have different sources of data for bicycle infrastructure. We have the Bike There map, and the Google also has a bike function, and we have the bike model in development.
Right.
And the BTA, I think, also has its own sort of bicycle reporting crash site, and we have kind of a rogue database of crashes. So there is more information as far as like looking at bike infrastructure and bike crashes, if that's something you want to look into in the future.
Yes, there are more data. Thank you.
Any other questions?
Okay.
Which one?
Yeah, what do you want to see?
So it seems like this works really good with the north-south and sort of east-west running streets. But I wonder about some of the angled streets, how well it would work with angled streets like Sandy Boulevard or Foster Powell. Because I'm thinking of how, like in raster, how it tries to draw an angled line with the stepping sort of thing
Right.
versus a vector. So if that would maybe obfuscate some of the data. Because I'm looking sort of like at Sandy Boulevard there, and it's not quite as clear
I
cut
think
as
it's
like 82nd.
I think we're probably seeing Sandy there. So yes, the pixelation, you get essentially a pixelation effect. It's as if you have this really huge pixel compared to what we've gotten used to these days. But they're still there. Powell's kind of a funny one because, yeah, it goes up and down in all different ways. And even Foster Road, I don't know. I was sitting looking at this with a map with street labels the other day and seeing that, I was able to kind of pick those out. I can't remember what this would be down here. Tay or Cindy probably does. But definitely some of the major roadways are there. But yes, that's an effect. But it's interesting how you can still make out the southwest corridor where Barber runs pretty well, even though it's one of the large angled ones. So, yeah, there is that issue. April.
Was there anything in the literature that looked at not using kind of individual continuous variables as an input to the problem, but instead looking at kind of neighborhood types or street types or archetypes? When you think about kind of the solution going to the complete streets or kind of a a bigger solution and not kind of looking at the individual variables, it seems like you might want to look at that. And was it, I mean, it's very different research design than what you were doing here, but did you encounter that in your literature at all?
There were some studies, Ladron and Guevara, I think, in New Hampshire, where they were looking at kind of the whole neighborhood, and they certainly were seeing that they felt that the neighborhoods that had more what I'd think of as a really nice complete street area, where they had a lot of the intermixing of a lot of pedestrians, but things that naturally slowed the cars down, they felt they actually had better they were seeing better safety in that area. So there have been some studies looking at that more. And if you're interested in more, my thesis is posted online, and in the literature review, I not only discuss the different papers, but there's also kind of a summary table of what factors different studies looked at. So that might help you point you in that direction if you're looking for other researches.
So, any other questions?
Yes. Fatal and injury level A. So incapacitating injury. So I grouped those together, feeling that both of those would definitely be major life-changing events.
Okay, so before we thank Kristie, just a reminder for the students that your assignments are due to the instructor of record by Tuesday of finals week at 5 p.m. So if you're in the civil side, it's Dr. Filiozzi, and if you're in the planning sections, that goes to Dr. Dill this quarter. So have a good finals week, enjoy spring break, and then we'll be back in the spring quarter, and I don't know who the speaker is for the first week. So thank you, Kristie.
Spring break, what a concept. Yeah, really. Well, we'll sign up.